Simplify. Assume all variables are positive. We have the fifth root of 243 times c to the 15th times f to the 5th. How do I find the fifth root of a radical? My teaching assistant Chloe is here with her latest cheat sheet notes. This first part right here shows you how rational exponent form does equal the radical form. When you have it in rational exponent form, your numerator in your exponent will be inside of the radical sign. Your denominator in the exponent will be the index or the root on the outside. If you are taking the square root of a variable, ask yourself, what is your index? This is how many you're going to have in each of your circles. Then you'll ask yourself, how many circles do you have? This is your exponent outside of the radical. And then your last question is, how many of your variables were not circled? This is your exponent inside the radical. Now that I have Chloe's cheat sheet notes, we can go ahead and start to simplify this fifth root. So in this problem, you will see that I am taking the fifth root of 3 different sections. I'm going to go ahead and split it up into the numbers and each variables and then combine all the answers together. So I have the fifth root of 243. What this is essentially asking us is, what to the fifth power equals 243? So start by trying 2s. 2 times 2 times 2 times 2 times 2. And then if it doesn't work out, go to 3s, and then go to 4s, and go to 5s, until you can find what will equal 243. So when I did this one, I found out that 3 times 3 times 3 times 3 times 3 equals 243. And I can go ahead and write that as an exponent, 3 to the 5th. Now, you will see that we have this in radical form. Let's go ahead and put it into rational exponent form. So with this, we have whatever is our exponent on the expression in the radicand will be our numerator in our fractional exponent. Whatever is the index or root will be our denominator in our fractional exponent. So what we really have is 3 to the 5th, 5 over 5. And 5 over 5 actually reduces to 1. And anything raised to the first power is the base, which is 3. So in this problem here, I will have a 3 on the outside. I will not have any whole numbers on the inside of my radical sign because there was nothing else left over. It was a nice even 3, so that's all that's going to be on the outside. Now let's look at c to the 15th. I went ahead and wrote c to the 15th in expanded form. Now, when you're taking a square root of a variable or a fifth root of a variable in this case, the first question Chloe wants you to ask is, what is your index? Because this is how many you're going to have in each one of your circles. My index or my root on this problem was to the 5th. It's 5, meaning I'm going to be circling in groups of 5. Each one of my circles must have 5 variables. Now, it says here, how many circles do you have? We have 3 circles. That means we are going to have an exponent of 3 on the outside. So that will be c to the 3rd power, or c cubed on the outside. How many variables were not circled? We actually circled all of our variables. So on the inside, we will have 0 as our exponent, c to the 0. We'll do the same thing for f to the 5th power. So we are looking at our index of 5. That means each circle must have 5 f's. We have 1 circle, so that means we are going to have f to the 1st power outside of it. And then how many did we not have circled? None. So we will have f to the 0 in the radicand. From here, we can go ahead and just simplify a little bit more. We know f to the 1st, anything raised to the 1st power is just the base, and anything raised to the 0 power is always 1. And then from here, we can reduce a little bit more. 1 times 1 is 1. What this is asking us is, what to the 5th power equals 1? Well, 1 to the 5th power equals 1. So I can just substitute 1 in for the 5th root of 1. Then from here, we just multiply everything together, and I get my final answer of 3c cubed f.